In these first set of notes for Unit 6, we have three types of variations. All right, we have a direct, joint, and inverse variation. All right, the direct variation you've talked about in Algebra 1. All right, the main thing is that it kind of looks like y equals mx plus b. All right, except for the b is the 0, all right, because it goes through the origin, right? The y-intercept is at the origin, all right? But what's different is we have this constant of variation is k, and that is sort of like the slope, right? If you have a direct variation. So if you're given directly values that vary directly, what you do is you write your equation and then you substitute. All right, so you're going to substitute, you write your equation. If it varies directly, you'd say y varies directly with x. All right, that's what that means. And then you substitute into the equation to get your constant. All right, your constant of variation is the slope. So for example, I have y varies directly with x. So this is the equation that I'm going to write down, y equals k times x. And I know that y is equal to 12 when x is negative 3. Those go together. So I'm going to substitute, and instead of y, I put a 12 because y is equal to 12. Equals, and then I don't know the constant of variation, but I do know that x is equal to negative 3. Okay, so I substitute it in there. And then I'm going to solve for k. So I would divide by negative 3, right? Divide both sides by negative 3. And so I would get k equals, right? K equals 12 divided by negative 3 is negative 4. So k equals 4. So my equation, all right, is y equals negative 4x. And that would look like the graph of this because it's plus 0, so it goes through the origin. But my slope is down 4, 1, 2, 3, 4, and over 1. Down 4, 1, 2, 3, 4, and over 1. Or I could go up 4 and left 1. Because a positive divided by a negative is a negative, and I would get that negative slope. Okay, so if I see a straight line going through the origin, that is a direct variation. Okay. Now we have this, it says find x when y is equal to 8. Okay, if they vary directly. So I'm using that same equation that I had before, y equals negative 4 times x. And so it says find x, so that's my unknown, and I'm going to substitute y equals 8. So over here we have 8 equals, this was my constant, negative 4, and then I have x, which I'm trying to find. And to find that, these are being multiplied, so I would divide by negative 4, divide both sides by negative 4, and I get x equals negative 2. Right? X equals negative 2. So these variations, it's a lot of just writing down an equation or a proportion and then solving, substitute and then solve. Basically, that's what it is. You could also use a proportion. Okay, a proportion is where you have 4 terms. You have y divided by x equal to y divided by x. That's a proportion, right? Where you have like A is to B as C is to D. And those make life easy. Proportions are really helpful. Because if you look at our original equation, y equals k times x, I could divide both sides by x, right? And then I get k by itself, that constant, is equal to y divided by x, all right? So if these are both if it's a constant number, then you can say for this is going to be true. These will be equal for all values of y and x in my points that vary directly. So we'll solve the problem this way. If y varies directly with x, so you have y varies directly with x, all right, and then I've got these different values. Y is equal to 15 when x equals 3, so those go together, and then find y when x equals 12. So the 15 and the 3 go together. That would be this first rate, okay? A direct variation is like a rate. I have 5. When y is 15, x is 3. All right, and I'll set that equal to, and y is always on top. Well, I don't know what y is. It says to find y, so I'm going to substitute for y. I'll just put in a y, I mean. And then, but now I can substitute for x because I know x equals 12, so x is in the denominator. All right. When you have a proportion, you cross multiply. So 3 times y is 3y, and 15 times 12 is 180. Okay, and then I would divide, right, I'm solving for y, so I divide by 3, and I get y equals 60. Everybody likes solving proportions, so that is a good way to go for these problems. If y varies directly as x, you want to focus in, that tells you what to do. Varies directly. Directly starts with a D, and you're going to think, I'm going to divide. All right, I'm going to divide. If it varies directly, I'm going to divide. I have y divided by x equals y divided by x. They vary directly. And then you substitute. All right, so I've got my proportion, and then I substitute. So let's see what I've got. X equals 6 when it's connected. This is our connector. Y is 0.5. So now I'm going to substitute. If y is 0.5, x will be 6, right? Those go together. And then it says find y, so I don't know y, so I'll just put in a y, when x equals 10. All right? Again, there's my connector. Those go together. And then now I'm going to cross multiply 6 times y. All right, for a proportion, this is my mean, and these are my extremes. The means always equal the extremes. And then 0.5 times 10. I'll do that, let's say I'm going to do that on my calculator, so I'll do 0.5 times 10. And I get 5. And then I want y by itself, so I've got to get rid of that 6, right? So y equals, and I could just leave it as 5, 6. All right, or I could write it as a decimal since y was a decimal, but I think it's repeating. So if I take 5 divided by 6, right, that repeats. So I'll go ahead and I could write that as a decimal. I could say that is 0.83, and I would put the bar over it to show that that repeats forever. All right. Now the next page. One more thing about direct variation. As x increases, y increases. All right, so if x is getting bigger, y is getting bigger. Or, as x increases, as x decreases, that's right, I'm sorry. As x increases, y could decrease. So x could be getting bigger, and then y is getting smaller, but at a constant rate. Okay? So let's check this out. That means I have a direct variation. So notice I have these divided by, okay? And so now I'm going to check out my first example. If y varies directly as x, all right, so now I've got y divided by x. There's my constant rate. This would be like miles per hour. And so if y is equal to 10, and here as x equals this is my connector, so these go together, so I have to have the 10 with the 2.4. All right, and now I've got x when, all right, so these go together, so x I don't know, so that's going to be x, but y is 15, so I'm substituting. So I write my proportion, and then I solve, and now I'm going to write an equation. You go from your proportion to an equation. So I like to have my x on the left, so I'll go ahead and do 10 times x first equals 2.4 times 15. All right, so 2.4 times 15 is 36. And so I'm going to divide by 10, so we get x equals 3.6, right? You just bring that decimal over one time and put it right there. If y varies directly with x, so I have y varies directly with x, so again I have y over x and y over x. Right, and so I'm going to put y equals 12 when, so these go together, x equals 2. So I have y is 12 when x is 2. I'm substituting, so proportion, substitute, and y when, find y, so that's my unknown, right? I don't know what y is. And then x equals 8, so that goes on the bottom. So proportion, substitute, and then I'm going to write an equation. So I'm going to multiply 2 times y, multiply my means, have to equal my extremes, 8 times 12. Right, so I get 2y equals 96. And then I'm going to divide by 2, so y equals 48. And if I want to see a direct variation from the table, I'm going to remember my rule about dividing. All right, I have to get a constant rate when I divide. Okay, so notice if I take, here's my x and here's my y, and so I have y over x, right, rise over run, and then I'm going to take 2 divided by 1, and that's 2, right? 6 divided by 3, and that's 2 again. 8 divided by 4 is 2 again. So yes, right, that is, y does vary directly with x. And the constant of variation, right, that's the constant, is 2. All right, and so the rule would be y equals 2 times x. And then over here, I've got x's and y's, right? And I want to see if it is going to vary directly, so I'm going to divide. I've always got to have y over x. So 4 divided by 1 is 4. 8 divided by 2 is 4. 11 divided by 3 is not 4, right? So that would be no. All right, they all have to have the same constant, so it does not vary directly. Excellent.